Hello class, today we're going to talk about radicals. But before we can talk about radicals, we've got to talk about a concept that helps us simplify radicals. And that will be prime factorization. Prime factorization is breaking a number down into its prime factors. So take, for example, 360. Okay? It's going to break down into 36 and 10. And then we continue to break 36 and 10 down. So the 36 will break into 6 times 6. And the 10 will break down into 5 times 2. Well, our 6's can continue to break down into 3 times 2, 3 times 2, times 5, times 2. So 3 times 2 times 3 times 2 times 5 times 2. If you type that into the calculator, you would get 360. Now, this bottom row is the row that I need in order to be able to simplify radicals. Okay, so let's see if we can actually do a couple. Now, these two are special radicals. Okay, because when we break down the square root of 25, well, that's going to break down into 5 times 5. So the square root of 25 is the same thing as 5 times 5. But when we're looking for simplifying radicals, okay, in this particular one being a square root, okay, I'm looking for two of a kinds. So I know the two 5's can jump out of the radical and become a single 5 on the outside. Okay, so that, again, this is known as a perfect square. Now, 81 will break down into 9 times 9, which then breaks down into 3 times 3 times 3 times 3. So if we put it in the radical, we get 4 3's. Now again, since we're looking for square roots, we're looking for two of a kinds. So I've got a pair of 3's here that can jump out. But I also have a second set of 3's that can also jump out. So we end up with the square root of 81 being 3 times 3, because we take the numbers that are on the outside and we put them together. So we end up with 9. So the square root of 81 is the same thing as 9. We'll try one that's a little bit tougher. What about the square root of 45? Well, 45 will break down into 9 times 5, which then breaks down into 3 times 3 times 5. So the square root of 45 is 3 times 3 times 5. Okay. Well, in the other two problems that we had, the first two, everything jumped out of the radical. Now in this one, though, our 3's will jump out because we've got a pair of 3's, but that 5 doesn't have a pair to jump out with, so we just leave the 5 under the radical. So the square root of 45 is equal to 3 times the square root of 5. So let's try another one. Try one last one. Now this one's 120. It's a little bit bigger. Okay, so we break our 120 down, and we get 12 times 10. The 12 will break into 4 times 3. The 10 will break into 5 times 2. This 4 will continue to break down into 2 times 2, then times 3 times 5 times 2. Okay, so this one breaks down into quite a bit. Now, when I'm putting that final row in, I like actually putting them in order. It just makes it easier to see. So we've got 2 times 2 times 2 times 3 times 5. So I've got a pair of 2's that can jump out. So we end up with 2, but I don't have anything else that can jump out. So we just put the 2, 3, and the 5 back together. So 2 times 3 is 6, times 5 is 30. So the square root of 120 is equal to 2 times the square root of 30. Now what if we don't have a square root? If you'll notice in this one right here, there's not anything in that radical right there. Okay? Well, if there's nothing there, then there's an invisible 2 there, which stands for a square root. The previous slide, we know that that was 2 times 2 times 3 times 5. So on this side, on this slide, we're looking for cube roots. So what we'll do, we'll just break the 120 down again like we did. Okay, and if we look back, so we'll do the same thing. So 2 times 2 times 2 times 3 times 5. But this time it's a cube root. So what I'm looking for is, instead of looking for 2 of a kinds, I'm looking for 3 of a kinds. So I'll take this 3 of a kind, they come out, and we're left with 2, okay, because that 2 jumps out, but the 3 and the 5 don't have a partner. So we write it as, we just put the 3 and the 5 back together to get 15. But we've got to remember to put the little 3 back in the corner, because this is a cube root. So anytime we have a cube root or a fourth root or a fifth root, whatever that number is here in the corner, that tells me what I'm looking for. So that's how we simplify radicals.